Hi dear students, welcome to today's class. Today we are going to discuss differential equations, 9th chapter of 12th standard. We are familiar with equations of the type x square minus 3x plus 3 equal to 0. Okay, the first three equations, already we are familiar with the equations of the type x square minus 3x plus 3 equal to 0. This is a quadratic equation in x, and sin x plus cos x is equal to 0. That is a trigonometric equation. In 11th standard we studied how we can solve the trigonometric equations and all. And x plus y is equal to 7. That is a linear equation. So we are familiar with the equations of the type x square minus 3x plus 3 equal to 0, sin x plus cos x is equal to 0, x plus y is equal to 7. Or quadratic equations, trigonometric equations, polynomial equations, cubic equations. We are familiar with such equations. Now consider the equation. Consider the equation x into dy by dx plus y equal to 0. Consider the equation x into dy by dx plus y is equal to 0. What is the speciality of this equation? This equation is actually equation in terms of derivatives. This equation is actually the equation involving derivative. Okay, so the differential equation means an equation involving derivative of the independent variable with respect to independent variable is called differential equation. Equation involving derivative or derivatives. Equation involving derivative or derivatives of the dependent variable. Dependent variable, here it is y, of the dependent variable with respect to the independent variable. Dependent variable with respect to the independent variable is called differential equation. Simply it means a differential in terms of derivative. Okay. So quadratic equation means if the power of x is 2, then that is quadratic equation. Trigonometric equation means the equation in terms of trigonometric functions, right? Similarly, the differential equation means equation in terms of derivatives is called differential equation. The differential equation, actually we have two types. One is ordinary differential equation and the second one is partial differential equation. Differential equation, two types are there. One is ordinary differential equation and the second one is partial differential equation. So this ordinary differential equation means a differential equation involving derivatives of the dependent variable with respect to only one independent variable is called ordinary differential equation. Actually, thus y is our dependent variable and y is in terms of x only. So only one independent variable we have. Okay, that type of differential equation is called ordinary differential equation. Otherwise, it is called a partial differential equation. In this chapter, we are going to discuss this ordinary differential equation. So this differential equation in this chapter, it means ordinary differential equation. In differential equation involving derivatives of the dependent variable with respect to only one independent variable. With respect to only one independent variable, that is ordinary differential equation. And in this chapter, we have only ordinary differential equations. So what is differential equation? It simply means equation involving derivatives. Equation involving derivatives is called differential equation, and we have two types of differential equations. One is ordinary differential equation and the second one is partial differential equation. And in this chapter we are going to discuss ordinary differential equation, and we will use some notations, that is this dy by dx, we can write it as y dash. Okay, it means first derivative. Then d square y by dx square, that we can write it as y double dash, second derivative. and d cube y by dx cube, that we can represent it as y triple dash, third derivative. But it will be inconvenient to use so many dashes as super suffix. Therefore, for higher order derivatives, we use the notation yn for nth order derivative, that is dny dx raised to n, d raised to ny divided by dx raised to n. It is very difficult for us to put that much dashes as super suffix. So what we will do is, in this case, we will represent it as yn. Okay, it means nth order derivative. So we will use this notations in the case of differential equations. Now, we are going to discuss order and degree of a differential equation. Order and degree of a differential equation. So order of a differential equation is defined as the order of the highest order derivative. Order of a differential equation means order of the highest order derivative. Highest order derivative. Order of a differential equation is defined as the order of the highest order derivative of the dependent variable with respect to the independent variable involved in the given differential equation. So this order, it means order of the highest order derivative. Okay, so we will consider one example. Just look at the fourth one. Just look at this fourth equation. D square y by dx square plus 2 into d square y by dx square minus dy by dx is equal to 0. D square y by dx square plus 2 into d square y by dx square all square minus dy by dx is equal to 0. Okay, this is a differential equation because it contains derivatives. This is a differential equation, and this order, it means order of the highest order derivative. dy by dx, that is first order derivative. D square y by dx square, that is second order derivative. Again d square y by dx square, that is second order derivative. So here what is the value of this order? What is our highest order derivative? That is second order derivative, that is the highest order derivative present in this differential equation. So in the case of that fourth equation, the order, that is equal to 2, because the highest derivative present in the equation number 4 is second order derivative. Okay, now just look at the fifth equation. Just look at the fifth equation. dy by dx, first order derivative. Again dy by dx, first order derivative. So we have two terms of derivatives here. First one is dy by dx all square. Anyway, dy by dx, that is first order. And the second one is also dy by dx, that is also first order derivative. So the highest order derivative in the fifth equation, that is 1. So the order of the fifth equation, that is 1. Now, sixth equation, dy by dx, that is first order derivative. Again dy by dx, that is also first order derivative. So the order of the sixth equation, that is also 1. So order, it means order of the highest order derivative. Order means order of the highest order derivative. So for the fourth equation, the highest order derivative present in the fourth equation is d square y by dx square. So the order is 2. Fifth and sixth, we have only the terms in terms of dy by dx. So the highest order derivative in the fifth and sixth equation, that is 1. So the order is equal to 1. Now, degree of a differential equation. Degree of a differential equation. Actually, to study the degree of a differential equation, the key point is that the differential equation must be a polynomial equation. Degree if you want to discuss degree of a differential equation, then that differential equation must be a polynomial equation in derivative. Must be a polynomial equation in derivatives. Then only we can define the degree of that particular differential equation. Degree of a particular differential equation. Now just look at the fourth one. Fourth one is a differential equation, no problem. We are going to discuss the degree. Okay, degree, it means first we should ensure that whether the given differential equation is a polynomial equation in derivatives or not. First we need to ensure that the given differential equation is a polynomial equation in derivatives or not. If it is a polynomial equation in derivatives, then we can define the degree. And the degree of a differential equation, when it is a polynomial equation in derivatives, we mean the highest power of the highest order derivative involved in the differential equation. Highest power of the highest order derivative. Highest power of the highest order derivative involved in the differential equation is called the degree of that particular differential equation. So in the case of degree, we need to ensure that whether it is a polynomial equation in derivative or not. If it is a polynomial equation in derivative, then we can define this degree, that is highest power. Okay, that is the highest power of the highest order derivative. Highest power of the highest order derivative is called the degree of the differential equation. Degree of the differential equation. Okay, now we will try to find out the degree of the fourth, fifth and sixth equations. Now just look at the fourth equation. This d square y by dx square, that we can write it as y double dash second order derivative plus 2 into y double dash all square minus y dash is equal to 0. Okay, if we replace this d square y by dx square by y double dash and dy by dx by y dash, then we will get the fourth equation as y double dash plus 2 into y double dash whole square minus y dash is equal to 0. This is a polynomial equation, right? That is a polynomial equation in y double dash and y dash. That is a polynomial equation in y double dash and y dash. So we can write the degree of that equation. Degree of that equation. This degree is equal to, what is the highest order derivative present in this? The highest order derivative present in this equation is second order derivative. Okay, the highest order derivative present in this equation is second order derivative, and that second order derivative, we have two terms in that second order derivative. We have two terms in that second order derivative. One is y double dash and the second one is 2 into y double dash all square. And degree means highest power of highest order derivative. Degree means highest power of highest order derivative. What is the power of y double dash here? That is 1, and here the power is 2. So the highest power, that is 2. Therefore, the degree of that fourth equation is 2. Now, fifth one we can write it as dy by dx means y dash. So y dash all square plus y dash minus sin square y equal to 0. Y dash all square plus y dash minus sin square y equal to 0. This is also a polynomial. Okay, this is also a polynomial in y dash. This is a polynomial in y dash, and the highest order derivative present in the fifth equation is first order derivative. The highest order derivative present in the fifth equation is first order derivative, and the power, we will check the power. Here the power is 2 and here the power is actually 1. Here the power is 2 and y dash means y dash all raised to 1. Okay, so the highest power, that is 2. The highest power, that is 2. Therefore, the degree of this differential equation is 2. Now, sixth one. Sixth one, dy by dx, that is y dash, plus sine of y dash we have. Okay, y dash plus sine of y dash is equal to 0. Just look at this differential equation. This is a differential equation and we can define the order. The highest order derivative present on this is first order derivative. So order is 1. But in the case of degree, this is not a polynomial. Okay, this is not a polynomial equation in derivative, because here we have sine of y dash, sine of y dash, cos of, tan of, any trigonometric functions. Okay, trigonometric functions, if you have the trigonometric functions in terms of derivative, if you have trigonometric functions or logarithmic functions in terms of derivatives, then that is not a polynomial equation in derivative. So we can't define degree here. This is not a polynomial equation in derivatives. So we can't define, we can't find out the degree of this differential equation. Okay. Now I'm going to discuss this exercise 9.1. In exercise 9.1, we need to find out the degree and order of the given differential equations. The first one is, divided by dx raised to 4 plus sine of y triple dash is equal to 0. Okay, just look at this differential equation. Order means the highest order derivative present in this. The highest, this is a second order derivative. Y triple dash means second order derivative, and the first one is fourth order derivative. So the highest order derivative present in this 4. Now degree, here we have the trigonometric function in terms of derivative. So this is not a polynomial equation in derivative. So degree we can't define here. Now the second one is y dash plus 5y equal to 0. Y dash plus 5y is equal to 0. Highest order derivative present in this, that is first order derivative. And the degree, since the highest order derivative is first order derivative, we need to check the power of this first order derivative. We have only one term in this y dash. So just check the power of that y dash, that is 1. So order is equal to 1 and degree is also is equal to 1. Now third question. Third one, ds by dt all raised to 4 plus 3s into d square s by dt square is equal to 0. ds by dt all raised to 4 plus 3s into d square s by dt square is equal to 0. Okay, just look at this differential equation. Find out the highest order derivative. What is the highest order derivative? This is ds by dt means first order, and d square s by dt square means second order. So what is the highest one here? Second order. So order is equal to 2. And this is a polynomial equation in derivatives. So we can write the value of this degree. Degree means the highest power of highest order derivative. Highest power of highest order derivative. Here the highest order derivative is d square s by dt square, and the power of this is 1. So the degree is 1. Don't write it as 4. We need to write the highest power of highest order derivative. Here the highest order derivative is d square s by dt square. That is the highest order derivative. Then we need to write the power of this one. Okay, that is 1. Now fourth question. D square y by dx square all square plus cos of dy by dx is equal to 0. D square y by dx square all square plus cos of dy by dx is equal to 0. Okay, look at this differential equation. Highest order derivative present in this. Highest order derivative is d square y by dx square. This is first order and this is second order. So the highest order is 2. Now this is not a polynomial equation in derivatives. This is not a polynomial equation in derivatives. So we can't find out the degree of this differential equation. Here we have cos of that trigonometric function is defined in terms of derivative. That trigonometric function is defined in terms of derivative. So we can't find out the degree of this differential equation. So this degree is not defined for this differential equation because this is not a polynomial equation in derivative. Fifth one. D square y by dx square is equal to cos 3x plus sin 3x. D square y by dx square is equal to cos 3x plus sin 3x. Okay. Highest order present at this, only one term in derivative, that is d square y by dx square. So the highest order is 2 and the degree. Okay, degree in this case, the degree is defined because this is cos of 3x. Okay, that trigonometric function is defined in terms of variable, not in terms of derivative. So we can write the degree and order here. Order is 2 and the degree means highest power of highest order derivative. Highest order derivative is d square y by dx square and the power of that is 1. Sixth question. Y triple dash all square plus y double dash all cube plus y dash all raised to 4 plus y raised to 5 is equal to 0. Y triple dash all square plus y double dash all cube plus y dash all raised to 4 plus y raised to 5 is equal to 0. What is the highest order derivative? Y dash means first order derivative, y double dash means second order derivative, and y triple dash means third order derivative. So highest order derivative is third. So order is equal to 3. Now we need to check the power of this highest order derivative. That means we need to check the power of y triple dash. That is equal to 2. So order is equal to 3 and degree is equal to 2. Seventh question. Y triple dash plus 2 into y double dash plus y dash is equal to 0. Y triple dash plus 2 into y double dash plus y dash is equal to 0. The highest order derivative here it is 3 and the power of that third order derivative that is 1. So order is equal to 3 and degree is equal to 1. Next one, y dash plus y is equal to e raised to x. Y dash plus y is equal to e raised to x. The highest order derivative that is first order derivative and the power of that first order derivative is 1. So order is equal to 1 and degree is also is equal to 1. Now ninth question, y double dash plus y dash all square plus 2y is equal to 0. Y double dash plus y dash all square plus 2y is equal to 0. Here the highest order derivative is second order derivative. Highest order derivative is second order derivative, and the power of that second order derivative is 1. So order is equal to 2 and degree is equal to 1. 10th question. Y double dash plus 2y dash plus sine y is equal to 0. Y double dash plus 2y dash plus sine y is equal to 0. The highest order derivative here it is 2 and the power of the second order derivative is 1. So order 2 and degree 1. 11th question. D square y by dx square all cube plus dy by dx all square plus sine of dy by dx plus 1 is equal to 0. Highest order derivative present in this, that is d square y by dx square. So order is equal to 2. D square y by dx square, second order derivative, that is the highest derivative. But the degree is not defined because the trigonometric function is defined in terms of derivative. The trigonometric function is defined in terms of derivative. So the degree is not defined. Degree is not defined for this equation. 12th one. Two x square into d square y by dx square minus 3 into dy by dx plus y equal to 0. Order the highest order derivative present in this, that is second order derivative, and the power of that second order derivative is 1. So order is equal to 2 and degree is equal to 1.